All right, today we're talking about Module 20.2, the shape, center, and spread of data. Uniform distribution is the shape where it's basically level. It's uniformly distributed about the numbers. So there's no real highs and lows. It's just all basically the same. Normal distribution is what we talk about with the bell-shaped curve, and it's a lot of times what we look at grades. That means there's more C's than there are A's and F's. A's and F's are the lower, and it builds up to that middle point of the C's. This is what that looks like on a line. We also have what's called a skewed distribution, and it is data that's distributed on one side or the other. So one side is definitely smaller, it's mounted up on the other side. So we have what's called a skewed right, which means the data is over towards the left, and a skewed left, which means the data is actually over towards the right. And I believe I have that named correctly. Let me double check my notes here. Yep. So we also have what's called the mean. The mean is the average. Let me see if I can center this just a little bit better for you. The mean is the average. That's where you add up all the numbers and you divide it by how many pieces there were. The median, which is our Q2, it's the middle value when they're listed in numerical order. We also have a standard deviation. That's how far the data is spread out from the mean. And this is the formula that we use to find it. We have what's called the IQR. That's the interquartile range. That's Q3 minus Q1, and we'll talk about that. So we're going to look at this set of data to begin with. We have the scores, 48, 53.2, 52.3, and 46.6, 49.9. And we are going to find the mean, the median, the standard deviation, the interquartile range for all the following. So we're going to start with the mean. To find the mean, we're going to find the average. So that means we're going to say X bar equals 48 plus 53.2 plus 52.3 plus 46.6 plus 49.9. And then we're going to divide it. We have 1, 2, 3, 4, 5 pieces of data. So we are going to grab our calculators. We are going to add them up. And we get 250 divided by 5, so that brings our average to be 50. So that's the average of those scores. Now, to find the next one, the median, means we've got to find the middle number. We've got to look at and list them in numerical order. So 46.6 is the smallest. 48 is the next smallest. Then we go 49.9, 52.3, and 53.2. So we want the middle value. So if we have 5 values, this right here is the middle, and we can go, okay, there's 2 values to the right, 2 values to the left. So our median, our Q2, is 49.9. Very close to the 50. All right, standard deviation. I'm going to hold off on that for just a second. I'm going to find the interquartile range because I've already found the median. To find the Q3 and the Q1, I actually have to use this value. So the Q1 is the middle between those two. It's the middle of the lower half. And the Q3 is going to be the middle of the upper half. Since the middle falls between values, you find their average. So we take 46.6 plus the 48, and we're going to divide it by 2. So our Q1 is 47.3. Over here, to find the middle of that, because you're just finding the average, we're going to add the 52.3 plus the 53.2 and divide that by 2, and we get 52.75. So the IQR is simply taking these two values, the 52.75 minus the 47.3. So we are going to subtract the 47.3, and so our IQR is 5.45. So So we're going to cover a little basics of the stats in this section, and then a little bit more. So we want to move on to the standard deviation, which is more of a challenging thing. I like to put my standard deviation stuff in a chart just like this. I think it actually helps you when you're trying to find the standard deviation. So my average, I've already found that. The mean is over here. So this goes 50 each place. And you're going to do a little bit of math. You're going to subtract them. So I can already tell you, like, this one would be -2, so 48 minus 50. This one is 3.2. This is 2.3. And let's see, this is going to be a -3.4, and this one's going to be a -0.1. Then you want to square those values. So -2 squared, that's going to be a +4. When you square a negative value, it's important to remember you have a positive value. And we're going to continue to square these. This is 10.24. This is 5.29. This is 11.56. And 0.01. And remember, those are all positive values. Now notice, it asks me to take the sum, because in our formula over here, after we subtracted it and we squared them, we add them all up. That's the sum. So we're going to take each of these values, the 4 plus the 10.24 plus 5.29 plus 11.56 plus 0.01, and we get the sum to be 31.1. Now, to finish our standard deviation, it says to take it and divide it by how many we had. So we're going to take this value, we're going to divide by 5, because we had 5 data values to begin with. So that gives me 6.22, and then it says we have to take the square root of this. So we're going to square root that answer. And we get our standard deviation to be a total of 2.49399278.3. We're going to round this to 3 sig figs, so we get 2.49. Now, there's a couple little other things we're going to talk about. I'm going to move the camera over completely so it actually can kind of see better. So we're going to move right over here. There's the marker. So we're going to do what's called a histogram. On a histogram, there's some important key features. The bars must touch each other. Categories have to go on the X, frequency on the Y. So we're going to draw a histogram for this data, and I just made up a few numbers. So it's kind of important to know the different frequencies. So 17 is on here, it's our smallest value. Our highest value is 22, so if you look at the bottom, our categories go from 17 to 22. We're also going to look at how many we have of each value. So on a histogram, we want 1, 2, 3, 4, 5, 6. I don't think we have anything higher than 6, but we're going to draw some bars to represent this. So 17 shows up just one time, so we're going to do this. I like to use different colors or different designs to make them stand out. So let's look at our 18. How many 18s up here do we have? We just 1 18. So I can leave that one blank because I shaded that one in. So 19, I have 1, 2, 3 19s. So I'm going to go up and over. And you want to make sure that when you do this, that your bars are kind of evenly distributed. They're all the same size. So use a ruler. 20, we have 1, 2, 3 20s. I'm going to leave that one blank so they stand out. 21, I have 1, 2, 3 21s as well. And then 22, I just have that one lonely 22. Whoops, and I'm going to leave that one blank so it stands out. And there is a bar chart. So my frequency goes up here. So these are my categories. And say these were, I don't know, scores on a quiz. We would want to title this. And then we want to write frequency on this side. So we're labeling our axes with what they are. Now, we're going to use that data, and we're going to actually make a box plot, or what's called a box and whiskers. So I'm going to do it right here. Box and whiskers is what it was called. Box plot is what it is now called. So we're going to work on using that just right here. So we're going to use that data. I'm going to make a box and whiskers. So the first thing you do with a box plot is we start with a number line. And since our numbers go 17 to 22, we may want to start, I don't know, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. You want to kind of go beyond the numbers you have in your value just a little. And we want to look at this data. So I actually want to list it out so that I can make my box plot. So I want to go, okay, so I have 17, 18, I have 3 19s, because I need to find my interquartiles, my Q1, my Q2, my Q3. I have 1, 2, 3 20s, 3 21s, and a lonely 22. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. That means I need 6 on each side to make it even. There's 2, there's 5, there's 6. So it's 1, 2, 3, 4, 5, 6, and 6. So what's between 20 and 20? Oh, well, let's see. That's 20. That's my Q, sorry, not 1, Q2. That splits the data into 2 equal parts. And we're going to split it again. Right here, the lower half. This is between 19 and 19 is 19. If you don't believe me, add 19 plus 19 divided by 2. There's Q1. And over here, when I go in the middle, it's between the 21s. So that's 21, and that's my Q3. We use those values, those median values, to actually draw the box plot. So the ends of the boxes go in Q1 and Q3, so 19 to 21. The middle will get marked in just a moment. It gets marked at 20. And then I have whiskers, which is what we used to call them, but I guess that's not politically correct anymore, so it's a box plot. So we're going to draw our line out to the minimum value, because our smallest value in our data is 17, to the maximum value, which is 22. And we've drawn a box plot to represent that data. So make sure you have it all down. We're going to practice this in class.